Welcome to Health Systems CIO's interview with Sameer Sethi, SVP and Chief AI Officer with Hackensack Meridian Health. I'm Anthony Guerra, founder and editor-in-chief. Sameer, thanks for joining me.
Anthony, thanks for having me. Really appreciate it.
Excellent. I'm looking forward to a fun chat. You want to start off by telling me a little bit about your organization and your role?
Absolutely. I'm a part of Hackensack Meridian Health. We are a health system based out of New Jersey. We are a total of 18 hospitals, all in New Jersey, around 500 plus care sites, around 40,000 team members.
Excellent. And your role, is it, I assume it's a fairly new role. Anything with AI in it is going to be. But tell me about your role, how it came about and sort of your mandate.
Absolutely. I now function as what they call the Chief AI Officer. I started out at Hackensack Meridian Health as the Chief Data and Analytics Officer. The reason this role was changed over to an AI officer was primarily trying to emphasize the importance of AI in healthcare. Our CEO, Bob Garrett, as you may, have heard him talk about, is very bullish on AI capabilities in healthcare and advancing in healthcare with AI and robotics process automation and enablement. So that switchover happened last year, but we've been doing AI for 3 years since I've been here. My responsibilities in the organization span across primarily four areas. One is the data, which is our capability where we ingest data from multiple data sources. We have 50 plus data sources across the health system where data is being generated for a patient, for our workforce, and various other ways. My team is responsible for ingesting that data and normalizing that data into structure that is most usable. The second piece of this is insights, which is where we now add business logic on top of the data that we have just captured in my previous description, and we start to add business logic. So that's what we call the insights piece, where we start to develop insights on top of the data so it's usable. That's where speed comes in, and fact and concepts of human factor engineering and a few things come in where we make sure those insights are delivered the right way at the right time to the right person. So that's the second part of my role, which is delivering insights. The third is AI, which is a mixture of what we did before, a lot of, which was machine learning AI, which is a lot of people call it traditional AI, and then now generative AI, which is now more prevalent, at least in the last 2.5 years or so. This is the team that builds use cases that use machine learning AI, that use generative AI to help our patients, to help our workforce. And the fourth is robotics process automation. This is where we write code to emulate human function. These are generally mundane tasks or repeatable tasks that a person may do that is of high volume, and we can have machines come and actually do this. So code actually does these repeated tasks so humans don't have to. That helps with speed, that helps with accuracy. Sometimes it even helps with workforce where it's too much of a boring task for someone to do, and therefore we're having an issue keeping somebody in that seat. So instead we actually automate it. So those are the four areas.
Go ahead. Yeah, so the robotic process automation, and maybe this is a silly question, but that's actually where we're dealing with a robot, like something physically doing something, or no?
No, it's not. This isn't the robot where it's actually hands moving, right? This is actually at times it's screen scraping, at times it's very back end. Primarily, if you have a function where you are in an application and you have two windows open, on your computer, and you're cutting and pasting information from the left screen to the right screen, or from one application to the other, we can have a robot do it. Obviously, it gets complex, but it gets as simple as that as well. We do this. I mean, I'm sure you do this, Anthony. I do this as well at times. But when we start to see processes that happen 50, 100, 200 times a day, that's when we say it's too simple for us not to automate this, and we'll go and automate it. So we have computer or code actually copy the information from the left application and paste it into the right application.
Got it.
Then submit it. And we have done this for process. Our first use case around this was FEMA. When you may remember, as a part of COVID, we were supposed to submit FEMA claims.
Right.
These were thousands. When
Right.
we spoke to a consulting company, they said it would take us, by the time we figured out what needs to be submitted, it would a company had told us it would take us 5 months to just catch up. We did this in under 24 hours. We wrote the code. It took a little while to write the code, but when
Uh-huh.
we pressed enter, we showed up the next morning, and all of it was done because bots actually did the submissions.
Right. Now this is funny, and I'm just having fun with this. We have to remember, I have to remember that there's no robots involved in robotic process automation. But, and this is a totally separate issue. We're not going to get into robots, but I have interviewed a CIO who's got a new tower he's putting up, and he's got like the biggest rollout of robots in the
Yeah,
country in healthcare. So there's robots too, but that's got nothing to do with robotic
yeah.
process automation.
This is
So
this
we're
is
going to
automation using code.
using code, right? Okay, so yeah, we've got all that fun stuff. So what I love here, what I find fascinating is that um, I was just at Vive, right? I don't know if you went to that one, but you and I are both going to HIMSS next week, which is why I'm speaking to you now. Um, so one of the huge themes at Vive, and I'm sure at HIMSS, is the importance of remembering, not that people forget, but the importance of remembering that AI is something that operates upon data, and that the most beautiful algorithms in the world, or models, or whatever you want to call them, aren't going to be able to do much if you have poor data. You talked about normalizing the data. You talked about that as one of the core things, parts of your job. You used to be a data guy. That was your title, right?
Yeah.
So you get it. I mean, it's interesting to me. I wonder if, talk about the importance of the data to AI. And it's almost like I don't know how much you want those separated. I mean, I guess you can have a chief AI officer and you can have a chief data officer, but being in charge of AI and having such a strong background in data seems like a very good idea.
Yeah, absolutely. So, and that's one of the reasons why I have kept that function close to my chest. Not because I think I do it really well and I enjoy it, but also because, to your point, Anthony, it is the foundation of how well the AI will be or not will be, right? I think it's all about the data. AI isn't magic, right? It works off of information or data that exists on a topic, about a person, about a certain specialty. Everything is grounded on data. I mean, we talk about, the likes of ChatGPT and Gemini and others. Well, those, what they call as large language models, they are trained on data and nothing else, right? So it is and will remain a data game. Without the importance of the right data, you will produce bad AI. I actually, now that I have this role, and it's created a bit of, sort of a, view on, what Hackensack and what this role is doing at Hackensack. I have spoken to a lot of folks that are organizations that are marching down that path. This is what should an AI officer do, and what portfolio should an AI officer have? And I've been a very strong proponent of saying that data and analytics should be a part and parcel of this portfolio. Without this, if you were to keep it separately into two places, I wouldn't say it doesn't work. It does. It will work, right? But you start to create bad barriers and slow things down. Keeping this under one umbrella is very helpful. As a matter of fact, robotics process automation as well. And I'm digressing here a bit, but I feel that, similar to how data has to be kept close to the AI function, I believe the robotics process automation has to be kept close to the AI function. We actually call it intelligence process automation, because it's not just about doing just simple tasks. AI now has capability of doing a bit more thinking, right? And if you were to combine that with robotics process automation, it makes sense, and does the need to, or at least a desire, and so far I've been successful in keeping these portfolios together. Data has to work with AI, has to work with RPA, and I think all that put together is what delivers value.
Yeah, it's very interesting. And I'm talking to myself as much as you here, but one of the things that I think it was a concept that was important for me to understand when it comes to this stuff is that AI is trained on a data set, right? It doesn't operate per se on the internet in general. It's got sort of an end date of when, right? So this model contains data that's up to a certain date. And unless you add new data to it, it is only operating on that data. So you can take a sort of a body of data and clean it up
Yeah,
before you use it in a model. So, that's
yeah,
kinda interesting. How
yeah.
how is this concept, understanding this helpful to people that are using AI, in charge of AI, or thinking about AI?
Yeah, it's an evolving area. I do want to say that, when you think about data being models being trained on a data set, that usually exists when there's no machine learning happening per se, right? So if you the large language models today, for the most part, are trained on a date and time data set, right? That's starting to change now, where a lot of the feedback loop information is coming in, but it's really expensive to train these large language models. So there's acquisition of data, there's cleansing of data, and then it's training of the model. Uh, and that's why these most of these models are point in time models, right?
Mhm,
Uh,
mhm.
if you move to the machine learning part of the house, it's a little different, right? A lot of capabilities that we have built today learns with the data that it actually processes. So there's a bit of a loop that comes in that adds to the data set. Still, there are a few more steps involved. It's not like it's reinventing something, as it learns, but there's some level of information that's coming up. But for the most part, Anthony, you are accurate. At least the new capabilities that everyone is talking about today is trained on a data set, and training of that is really expensive. It has some issues. We have generative AI capability that's learned or has information by a certain date. So if you were to ask of it things like, what is the weather like today, it
Mhm.
actually does not give you an accurate answer. It's
Right.
changing. Google and OpenAI and others have come out a way by which they have opened the doors for it to search the World Wide Web and get that information better. But that's not training. It's not trained on that data set. That's just fetching information from places.
Yeah, so it's interesting, right? So you can have a model or a data set, and you maybe your queries can only operate against the data that's in that set. And as you said, for example, if you ask it for today's weather and the data set ended 6 months ago, it's not going to be able to give it to you. But you can upload usually current information. You can give it. So it can't doesn't have it, but you can give it certain information and say, hey, give me information or give me some analysis of this data. So it can
Yeah,
still operate on data it doesn't have if you provide it that data.
yeah.
Tell me,
And
am I
yeah, that
right?
is correct. But remember, there's a difference between getting the data and building intelligence on top of it. A simple way of thinking about it is the intelligence piece of this is something that it has to be trained on. Whereas getting the data and presenting that can be done without teaching the model, right? So
Mhm.
the weather is a good example, right? If you were to ask for it for, give me a sense of what weather would be, what temperature would be in Hawaii, 6 months from now, what it would do is that it would use the information about Hawaii and its weather patterns in the data set that it was trained on,
Mm.
and it wouldn't factor in generally the weather from today, when it's giving you an answer. So it's a difference between, and that's where the capabilities are evolving. A year ago, it would actually just give it based on the information that it was, that it had. Today, it's able to do as I described. It can give you today's weather, but it's just fetching that information and giving it to you. It's not using it to think.
Yeah, so it's interesting, and I wanna make sure we're being other than answering some of my questions and educating me, I wanna make sure we're being useful to the people that are gonna listen to this. So, um, you talked about it may extrapolate from the information it has. So if you ask it about the weather, let's say you ask it about the weather today, but the model was only updated up to 6 months ago. One of the issues seems to me has been that it will give you the weather of today almost, and this is where we come to hallucinations.
Yeah.
It won't say, hey, my data is only up to date for 6 months ago, but I think this is what the weather might be. It'll say, here's what the weather is today. I guess that's what we call a hallucination. Sometimes it's completely wrong. Um, where are we with this? I mean, I heard people at the show, at the Vive show, talking about we they don't know if we're going to get away from hallucinations or how quickly we will, or obviously it's degrees of a problem. So maybe we get away largely from them. And this also relates to the issue of the human in the middle concept, or I'm sorry, human in the loop. So this is why we're very concerned about removing a human from the loop because of hallucinations and what's at stake with some of these decisions, especially if we move into clinical decision support. And let me finish up before I give you the floor. I also heard someone very influential say, whenever you talk about maintaining a human in the loop, you're limiting scalability. So, yeah, it sounds good. It makes everyone comfortable. But in a purely productivity sense, that is a very limiting factor. So, your thoughts?
Yeah. So let's first talk about hallucinations, right? Uh, Hallucinations, the way I best describe it is generative AI, not machine learning AI. Generative AI has a problem with saying, I don't know.
Right.
That's, that's so, and when that problem exists, it makes things up based on what it knows, right? And they're not factual at times. There is no way to completely eliminate hallucination. That's the way, large language models are built up. There are ways to reduce it. And that's where I think the two concepts comes in. One is fine tuning a model, and something that's one which is I think a tedious task, and but organizations are doing it. And the other is what's called RAG, which is retrieval augmented generation, right? This is where we, in some form, do two things. One is we give it a data set, right, on top of what it's trained on. So, Gemini is a Google large language model. We use it, and it's trained on a data set that Google had, and then we will bring in our own certified data source to sit on top of it, and think of it as a filter. So first it asks the large language model for a response, then it refers to a data set that we provided, right? And this is the process, what is called RAG, to come up with a better answer. So that's one way of reducing hallucinations. The other is fine tuning. Fine tuning is a way by which we are telling, for lack of a better term, how many chances or how aggressive the answer needs to be. And these are, put together by the large language model organizations. You don't, there are some gives and takes when it comes down to, fine tuning. As you fine tune further and further and further, it's the use of it, you limit it, but at the same time you do get better answers. So as you really fine tune it or make it tighter, it starts to actually say, I'm not going to answer that question. So it makes less things up. So a combination of one, understanding the use case, what it is, two, fine tuning the model or the response, and three, applying RAG to this capability starts to reduce the hallucinations, right? But again, keep in mind, it all starts with understanding the use case. Sometimes over fine tuning or over ragging is also not good, right? And that's where I think, Anthony, human in the loop comes into place, right? You have to look at, again, the use case and decide where the human loop and how much of it makes most sense, right? I'm digressing here a bit, Anthony, but what's happening today with around hallucinations reminds me of, and I'm dating myself here, right? Like when the internet came out in 1995, right? And we all got our modems and we were able to connect to AOL. So we had access to the internet, but we had to still learn how to use it. And I think that's what's happening here, right? With large language models and this new capability, we have to learn how to use it. And as a part of that learning, right, we'll have to figure out where, in what situations, and how much the human in loop has to come in. And based on that, we will rag it or fine tune our models, right? And all this will eventually come together. But there are ways and means by which you can reduce the hallucination considerably. You can bring accuracy into the mix. It comes at a cost, right? Human in the loop is very important. I mean, there's no ifs and buts about it, especially in healthcare. I mean, we at Hackensack Meridian Health are focused on that, there is going to be a human loop. How much of it, Anthony, to your point, is still TBDs and it's based on the use case.
Very good. So we want to reduce hallucinations. Is the ultimate goal to get the generative AI to say to a query, "I don't know"? Is that really, really hard to get it to admit it doesn't know and to not provide an answer?
Yeah, it's not hard, right?
Mm,
It's not hard to do that, but again, you start to limit how much it can think. Keep in mind, one of the reasons why also people like generative AI is because of its creativity, right? So,
right, right.
it's also about if you start to put barriers and blocks around what it can do, you start to limit what it will do as well, right? So
Mm,
there's gives and takes about it. Is that the goal? Yes, absolutely. I think reducing hallucinations would be key. But again, you have to factor in the cost of doing that, right?
right,
You will limit its use, you limit its capability. It comes at a cost from a price perspective to fine tune these models, and ragging these models is an expense as well for the organization. So it depends on what it is. One thing I want to add here is that, unfortunately, the way the world today thinks about generative AI, they think of it as it's this one thing and it can answer everything.
mhm,
We at Hackensack are going away from that, right? It's not that one thing. It's just like we have a software for processing payroll, and then we have a process. We have another software for where that is used by the folks that do hiring, right? We are moving into a place where there's a large language model for a purpose, and there is
right,
very little bit of all-purpose large language model, right?
right,
Or all-purpose generative AI. This all-purpose generative AI is not doing justice to anybody, because
right,
somebody that's looking for an accurate answer is going inside and looking for an accurate answer from a general capability, which is not fair to the large language model either. So we're actually going to places where we are fine tuning our use cases and saying, here's a generative AI for HR, here's a generative AI for nursing. And I'm saying it in this order, but my point here is that the world is slowly moving to a place where there's a generative AI capability that's fine tuned for a purpose. And that's what's going to deliver accuracy. That's what's going to deliver less hallucinations.
and is it fair to say that generative AI is a specific tool which works for specific things? And this isn't my original idea. Other people have told me this, that generative AI is good at certain things and it's really good at the things it's good at. But for example, it's not good at everything. And if machine learning may work some much, much better for specific tasks. So you need to understand there's different tools for
Yeah,
different jobs, and generative AI is not good for everything.
absolutely. I'll give you an example. We at Hackensack are very big on using AI for disease detection, right? And we don't use generative AI for that. We use
Mhm.
machine learning technology.
Right,
It's been when we built a model for CKD detection, right, chronic kidney disease, and we don't use generative AI for that because it's not built for that. Whereas on the other side, we use generative AI for clinical note summarization. This is a capability where we are looking for large amounts of data within a patient chart and providing a summary to a clinician, obviously
yeah,
identifying key attributes, right? But that's where the power of generative AI comes in. Generative AI is very good at generation and summarization. It is
right.
not good at detection. For
I mean
detection use cases, we're using machine learning.
you're absolutely right, and I'm laughing to myself because I think, we've seen this before. It reminds me of blockchain, right? Blockchain is very good at a specific thing that it does with the Bitcoin and whatever. It's really good at that thing. And everybody said, a few years ago, this is amazing at this thing. Well, it's got to be amazing at other things, or there's got to be other ways we can use it. Well, not necessarily. It didn't really sort of take off in healthcare.
Yeah.
And I think we're doing maybe something similar with generative AI, which is it's amazing at this clinical note summarization, which is a really important issue. It's like the perfect tool for something that really needs to be fixed. And people are just getting going, if it's so good, it's amazing. Where else can I use it? But it's the kind of situation where if you're trying to you got a nail that's got to go in a piece of wood,
Yeah.
and you got a hammer, and
And
you go, look, go ahead.
yeah, I some degree at times, blame the likes of Chat GPT for this because they came out so fast at this and people adopted it and it was free and they started using it for everything. I've used this analogy a few times in conversations where I say, the likes of Chat GPT, could be Gemini, could be, Chat GPT, are the high fructose corn syrup of sweeteners.
Ah,
And the reason I say that is because it does the job, it makes things really sweet, but it's not good for everyone. It's not good for all use cases, right? You have to fine tune it, and some sugars for certain dishes or certain patients, right? You need a special kind of a sweetener versus using high fructose corn syrup. So that's the analogy that I generally use, is and unfortunately or fortunately, when you think of generative AI, you first think of the likes of ChatGPT, right?
sure.
And you cannot go in, and it's not wise to go in and help it detect a disease, right? It's good to get some information about a disease, right? But that's as far as it should go. It should not be in the prediction game. It should not be in the detection game. That's when you need a doctor that is enabled with AI insights, right? But it's still a doctor, right?
Right,
If you want to
right.
get treated.
And so, I think it's machine learning, which is detecting anomalies in imaging and scans. It's machine, then that works really
That
well
is
for
all
that.
machine learning.
We don't have Chat GPT analyzing images, right?
Yeah,
Because
yeah.
right,
As a matter of fact, even just thinking about that from a human in the loop perspective, right? We use AI there to help detect something in an image, but then we use that for prioritization of the review of images. It's still a human going in and doing so.
right.
What we're trying to do, we're in the business of making clinicians smarter, faster, right? Using AI and not having AI replace them.
I'm gonna ask you one more question because we're almost out of time. This has been a great chat. I really appreciate it. The idea of providing, and this is a premise of mine, people in your position or IT executives in health system, your job is to empower the amazing clinicians that work in the health system, right? Really, really, really smart people, including researchers and surgeons and all kinds of doctors that want to do cool stuff, right? And there's technology out there, so some of the generative AI we discussed, that they want to use to try and figure out insights and do cool stuff. So part of your job is to let them do this in a safe, secure, compliant way. Does that make sense? Like giving them like little secure sandboxes to go have fun and play and be you. But
Yeah.
tell me your thoughts about how you do that.
Yeah, yeah, absolutely. I mean, I spoke a lot about, the likes of Chat GPT, right? So the first generative AI use case what we built at Hackensack was our own instance of this, which would secure the data and make sure it doesn't start to leak, right? Similar to that, we have provided various capabilities where clinicians can come in and experiment with this capability. We haven't gone to a place today, honestly, where these folks are actually building capabilities, right? I think there'll be a time and place for that at some point. But today we are allowing them to, ask a question and then giving them the option of using different large language models to get the right answer. We're helping them fine tune their prompt or the question that they ask using certain capabilities. So there is some level of sandboxing and abilities that
Yeah.
we're providing to them, right? That are experimental in nature. But obviously, that is much needed. This I think the spirit that you're describing here is much needed because as a result of that, we actually collect feedback. This is when
Yeah.
clinicians come in and say, I tried this, it didn't work well. Can you help me find a better thing? So this is a part and parcel of my role and my team's role where we're actually, providing capabilities to clinicians, getting feedback from them, and then turning them into true valuable use cases that are delivering impact for the patient.
Well, Samir, this has been an incredible amount of fun. I've really enjoyed it. I think the readers are going to enjoy it, and I hope I can reach out to you down the road and get some insights again. So thank you so much for your time today.
Thank you, Anthony. This is great. Really appreciate it.